have a look at this question, and if you need a bit more time, then just pause the video. Some of you have been trying this question in class. Now, before we continue, I would like to remind you of a certain formula. Now, I'm almost getting tired of the number of times I've had to remind students of the same formula. You, as you watch my videos, hear me say the same thing. B is positioned higher up than A. So when you apply the change of base formula, it's log of base C, whatever you're changing it to. The B goes on top of the fraction, and the A goes on the bottom. Initially, B was positioned higher up, so that's how I remember it. Okay, that's one formula that everyone needs to know. And the other one is if I wanted to swap the A and the B around, so if I wanted to swap those two around, then I could do that, but I have to remember to 1 over. Brilliant. So these two can swap over, but it's just 1 over. Okay, so I need to remember these two. And as I keep saying, this is simply a special case of that, where C is B. Okay, because log of base B of B is 1. But you know, even if you don't know that, which you should know, the rule is if you swap these two, it's just 1 over. That's a quick, easy way to memorize this. So here I could see that the bases are different. One is with base X, one is with base Y. Well, I could apply the second rule, which is to swap the X and the Y over, let's say here, but I have to take the reciprocal, it's 1 over. So let me just do that. So it's log of base X of Y plus 1 over log with base X of Y is equal to 5 over 2. Now, here I've got a fraction, okay? Got a fraction. Yeah, I've swapped it over, so now this base has changed. Yeah. Now, so this term will now become that term. I've got here a fraction. Now, the best way to deal with this is to multiply everything through by log with base X of Y. So let's do that. Okay, so I times this by log of base X of Y, and I get log of base X of Y squared plus 1 is equal to 5 over 2 log base X Y. So all I've done is multiplied through to get rid of the fraction. Now, I have here what is a quadratic with log base X Y. So let me just show you a substitution. If I said let Z is equal to log base X of Y, then if you'd like to pause the video, you could see the resulting quadratic that is formed. So if you pause the video and continue, what you end up getting is Z squared plus 1 is equal to 5 over 2 Z. Multiply through by 2, 2Z squared plus 2 is equal to 5Z. So 2Z squared minus 5Z plus 2 is equal to 0. Now you can see it's very straightforward. If we take minus 2 and minus 1 there, we can solve it for Z. So Z is equal to 1/2, or z is equal to 2. Okay, but if I just go back to what z is, z, remember when we're trying to solve this, we're trying to find x and y, we're not trying to find z. We've just made that substitution to make life easier for ourselves so we can spot the quadratic. Okay, so z is equal to log with base x of y. So now let me take my first solution. Let me take this one, whole number, z is equal to 2. What does that mean? That means that log base x of y is equal to 2. Now, again, the usual rules of logs. That means that y is equal to x to the power of 2. Yeah, when the x goes up. So from here, I've now formed an equation in x and y. And back to the question, they tell us that xy is equal to 64. So let's call this equation 1. And equation 2, xy is equal to 64. Well, I know that y is equal to x squared, don't I? So y is equal to x squared. I can sub that in, can't I? So I can say, therefore, I'm going to sub in y for x squared. X times x squared is x cubed, which is equal to 64. And so x is equal to the cube root of 64, which is 4. And I can see that when x is 4, y has to equal to, well, let's just choose it. Xy is equal to 64. Y is equal to 64 over 4, which is 16. Okay, so I've now got one set of solutions. Now, if I go back, so I've dealt with that case. What if z is equal to a half? Let's now deal with this. Z is equal to a half. So that means, remember what z is? Z is equal to log with base x of y. So let me write that down. Log with base x of y is equal to a half. That means y is equal to x to the power of a half. Okay? Or I can, if I square both sides, I can say that y squared is equal to x. And so let's have a look at this one. So this is, let's say this is equation 3. And this is equation 4. Xy is equal to 64 as given. Okay. I can, again, now I could substitute where I see x, I can put y squared. So y squared times y, that gives me y cubed is equal to 64. And therefore x is equal, so y is equal to 4. Last time we had x equals to 4. So now when y cubed is 64, y is equal to 4. And therefore x is equal to 16. Brilliant.